Hello, good morning. First of all, let me introduce myself. My name is Jorge Elena from Visit Technologies. I would like to say thank you to gvSIG Association and Mario and Alvaro for their trust, for trusting in me for this session to chair it. And I would like to thank you all for attending. It's early in the morning and the weather is not particularly nice, so thank you for coming. There will be a question round after all three lectures. Our first speaker is Daniel Lopez. He's an engineer, a computer engineer by the Polytechnic University of Valencia. He's a technical manager of Temple, a project for geographic information systems in the property register of Spain. Hello, good morning. Thank you for being here in a rainy day. Thank you. I'm here to talk about Temple, a geographic information system implemented for the registration of properties in Spain, or the poll tax register. These are the goals of my talk: to show you the Temple SIG tool and to illustrate it with an example of registered properties. Right, our graphic system aims to graphically represent properties in a geographic information system of all properties recorded or registered with the poll tax office. Our legal framework is the Mortgage Law or Act, Article 9.1. Registrars will be able to use computer tools for registering properties. These are the operations included in the procedure. First of all, location of the property in the territory, then graphic basis configuration. Next, the registrar proceeds to validate the property into the system, and lastly, all data are coordinated between the poll tax office and the cadastre office. Right, our registration sheet is the very starting point. What information is compiled in this particular sheet? Well, the most important details have to do with a description of the property. Basically, this includes the location of the property, a description of the area, the boundaries, the owners, the street, the address, a number of details and data. Additional information is also included, such as purchases, mortgages, etc. In the geographic information system, for location purposes, we have a location and search module. This module is intended to identify all parameters on the registration sheet, namely cadastre reference, and we're going to have a look at this example. Cadastre reference, poll tax reference. This is an urban plot with properties. Once all parameters on the registration sheet have been identified, all of them, boundaries, cadastre reference, etc., the property is configured. Configuration consists on graphic registration of the plot and alphanumerical data. Let me explain. On the one hand, by using a number of editing tools, we will register the perimeter of the plot, and additional data will be included to complement that preliminary definition. For configuration, a number of graphic tools can be used. For instance, self-adjustment, as you can see, based on boundary lines. Editing also relies on cadastre information. A particular tool copies all the information of the cadastre onto our geometry. Once the property is configured, we continue to do the alphanumerical configuration, which requires 3 questionnaires to be filled in. One for validation metadata, data that actually allow the registrar to validate the property. Then we have configuration scenario data. These data explain how the graphic representation was made. In other words, how all the boundary lines were configured on the basis of cadastre information, on the basis of topographical information, etc. And finally, temporary criteria. These metadata show the causes why the registrar may render the graphic database invalid. Once configuration is completed, the registrar, with his own responsibility, may validate or not the property. Validation grants the plot or the property a validation status, and in our temple system it is represented by means of captions, as you can see. What functionality was implemented to carry out the validation procedure? Well, first of all, access to the application was restricted so that authorized users only can gain access to validation procedures. Secondly, a panel was included, a display window, as you can see, has been included for the registrar to browse through the properties. You can zoom onto the plots, onto the properties, and of course the registrar is shown in a very easy way all metadata filled in during the configuration procedure, which will help the registrar make a final decision to validate or not validate a particular property. After the validation procedure, coordination takes place with the cadastre office. This coordination step allows the registrar to compare data in both institutions. Let me show you an example to illustrate that the same information might not be stored in the registrar's office and the cadastre office. On the right-hand side, you see a number of plots which are not included on the left-hand side, which is the cadastre photograph and information. On the right, we see pieces of land, plots that were registered with the poll tax office some 30 years ago. They were registered, but an execution deed was not completed. So which of the two is the most valid one? Well, both of them, because the properties in the registrar's office have been mortgaged and eviction orders have been issued. So they are a matter of fact, they are absolutely real. So with this type of relationship between the cadastre and the registrar's office, interoperability is ensured for a mutual knowledge by both institutions, both of them being able to inform the owner at any time. The functionality implemented here is a window, a display view, which allows the user to enter data from both institutions and read them automatically. If the cadastre reference matches the information in the registrar's office and both geometries match, the property is finally given coordination status by means of a caption. Here are all possible coordination statuses. Ideally, C for convergence should be ticked, should be checked. That means both institutions have the same information, but areas, for instance, may be different. The footage of a property may differ. To wrap up, Temple allows us to locate the property, configure the property graphically and alphanumerically. The registrar will then validate it, and finally data will be coordinated in both the registrar's office and the cadastre office. What else can we do with Temple? Well, Temple allows us to enclose interesting information into the database by using the documentary handler. We can also analyze the environment of our property by resorting to two modules, environmental information and environmental inquiries. We can also carry out economic data analysis. And finally, and most importantly, we can generate reports with all the data and information in previous modules. The documentary handler is intended to associate documents to the graphic database. It is very easy to gain access and to have printouts. Documentary data that may be of interest to us includes drawings, plans, as this one on the screen. It might be useful to enclose, to attach a drawing to the location of a particular property, or office maps, data from the office documents, if it is an office, etc., anything. And you will also be able to display captions to facilitate the viewing of properties with associated documents. The environmental information and environmental inquiries module allows us to combine multiple maps to the cadastre database. What maps, what cartographies do we use here? Well, it very much depends on the conditions of a particular poll tax office. We may have an interest in having maritime or coastal maps, farming land maps. And now the assessment module. Although the registrar's office is not intended to appraise a property, economically speaking, economic information can be drawn by means of this module. We have perfect geo-referencing information which can be used for appraising the property for a number of purposes. The functionality in this case is an advanced filter, which is summarized here in the interface. From this window, we can set all filtering criteria we might be interested in for the property or for the plot, and end up with a number of indicators for us to carry out statistics and statistical analysis and produce a final report. And finally, reports. These are some of the documents generated by Temple or from Temple. Here we see a registered graphic database with an ortho photograph, a coordination certificate by the cadastre, with vector cartography. In this case, the plot of land matches the information for both institutions, the cadastre and the poll tax office. Here we see 4 views combining information from the forestry department, the cadastre, and here we have another view, 2 different views. This module is particularly interesting because it allows us to simply, very easily configure the final appearance. It is done in a very straightforward way. And lastly, let me show you the appraising report or appraisal report with the data filtered out and the financial conclusions drawn. To finish with, I would like to show you, or I would like to tell you that apart from what I showed you, The system includes a number of internal tools to be able to process all cartographies used by the tool. We developed a module that allows us to import POSIS databases to be exploited and made the most of by the tool. And we have also imported bits and pieces from other databases to be able to have their geo-referencing. Finally, I would like to show you the architecture of the application. As for the server, we have a POSIS spatial database, including data from the poll tax office, the cadastre. And on this intranet, clients with Temple install can gain access to the database themselves. Temple customers or Temple clients use the modules that we developed, which I described earlier. And a few conclusions. Temple does meet all needs in the registration department, as it generates very valuable information when a particular citizen goes to the poll tax and asks for a piece of information. Thank you. Well, I didn't tell you. Daniel is the technical manager of this particular project.